Okay, now we're on 2.4, and so that's awesome, right? And so let's look at it. Okay, 2.4 is on meeting the intercepts. And so they're going to be your friends, and they are already your friends. You just didn't know their names. And so the X-intercept is the point where the graph crosses the x-axis. And recall, a point is an ordered pair. And so I want to come down here, and some of the graphs that they've given you have more than one X-intercept. And so that's why they have the S there, just in case there's more than one. This particular one that I have chosen only has one. And so this is where the graph is crossing the x-axis. So here's the x-axis right there at -5. And so the X-intercept, written as an ordered pair, is the ordered pair -5, 0. Your book also writes it in shortcut notation, and I'm okay with both. And so, but it's really good that people know that it's 0. So that's the reason I want to make sure that everyone knows. They'll write the X-intercept as -5, and I'm okay with that as well. And then the Y-intercept is the point where the graph crosses the y-axis. So we come here and we look at the y-axis, and there's the graph crossing it. So the Y-intercept, and I'm going to write this as an ordered pair. So over 0, up 2. And the Y-intercept in shortcut notation is 2. And I'm okay with you just writing the shortcut notation, but why I wanted to make sure that we wrote these is because it's no coincidence that the X-intercept occurs when the Y value is 0. Because how would you stay on the y-axis? Only if your y coordinate was 0. Don't move off the axis, right? Starting from the center. Go over left or right, but don't go up or down. If you go up or down, then you're going to move off the axis. And the same with the Y-intercept. If you want to stay on the Y-intercept, your x needs to be 0. Your left and right needs to be 0 because you don't want to move left or right. Otherwise, you'll move off the y-axis. So you do go up or down. So the next thing they tell us is, well, you can find the X-intercept and the Y-intercept from an equation. So this is finding the X-intercept and the Y-intercept from a graph. But you can find it from an equation, and you just have to think about what we said. The X-intercept happens when y is 0. So that's what they say. The X-intercept happens when you let y equal 0 and compute x. And then you can write it as an ordered pair. What you found for x, comma y, because y is 0. So we'll give a try to that. So if they're asking us to find the X-intercept, then we need to put in 0 for y. And then we just have to go do the arithmetic. So 2 times x minus 4 times y, but we said y was going to be 0, equals 8. And then this is gone. And I know a lot of people say, they call it the cover-up method when you're using the zeros, right? Because that part's gone. And we end up with 2x equals 8. And they say you cover up that one because 0 times 4 is 0. And so I end up getting to solve 2x equals 8, which is x equals 4, right? And you can see that that's the answer. Or if you're a person that solves it all the way to the bitter end, you could divide by 2, x is 2. And then how you find, so there was my work for the X-intercept, right? And how you find the Y-intercept, well, the Y-intercept is x equals 0. And that's what they say here. To find the Y-intercept, you let x be 0 and you compute y, and then you can write it as an ordered pair. And so I tell myself, if you're trying to find the X-intercept, you let the other guy be 0. If you're trying to find the Y-intercept, you let the other guy, which is x, be 0. And so that's how I say that to myself. Let the other guy be 0 to find the intercepts. Well, picking x as 0 is my favorite point. Picking y as 0 is one of my second favorite points, unless the equations solve for y. So I'm going to do the work here. So 2 times 0 plus, whoops, it's minus though. Be careful with my sign. minus 4 times y equals 8. This is gone. So I'm going to divide by negative 4. Y equals negative 2. And then it says, find the x-intercept and find the y-intercept, and then use the intercepts to sketch the graph. So over 2, up 0. Over negative 2, up 0. And so I hope that you're seeing that I made a boo-boo, because I made a boo-boo on purpose. And that happens to people quite a bit. Now, a couple of ways I can know that I made a boo-boo. This was supposed to be on the x-axis, and it is. This is supposed to be on the y-axis, and it is not, right? It's not on the y-axis. But the other way to know is it didn't ask me to get another point as a checkpoint, but it's always good to get a checkpoint. It's always good to check your work. And so this is extra bit of work, but it's a checkpoint, right? And choose anything not already in your list. So you can't choose x is 2, and you can't choose y is negative 2, or x is 0, or y is 0. I'm going to sneeze. But you can choose anything else. It's all the smoke in the air that we got going. And so I'm going to pick, and you could choose whatever you wanted. I'm thinking about picking y is 1, just because I'm looking at it and I'm thinking that that might make a good number. And so, but you could choose whatever you wanted. So 2x minus 4 times 1 is 8. 2x minus 4 equals 8. Add 4. 2x equals 12. And so that is a good number. That's 6. X is 6. So when I plot this point over 6 up 1, now I'm even more convinced that I have a boo-boo going, because they're not supposed to make a triangle, even though this is kind of an obtuse triangle. They're supposed to make a line. And so I could check my points to make sure that I have got them correctly plotted. And so it should have been 0 over 0 down 2. And now you can see, oh, wait a minute, that's still not looking too good. So something is up. Oh, did you notice that? I didn't notice that, but now I know. See how this is not a line. That's another crazy triangle. When I put my line through it, I made a boo-boo on purpose and had a boo-boo on accident. See how those do not include that third point, and that one, those two don't include the third point, and these two don't include the third point. So now I'm kind of fairly certain I've got them all plotted correctly. Over 2 up 0, over 2, over 0 down 2, over 6 up 1. And it was only my checkpoint that let me know that there was a mistake. If I hadn't had my checkpoint, I would not have known there was a mistake, because I would have had those 2 points and I would have thought it's perfect, right? So my checkpoint actually saved me. I didn't make a mistake on purpose on this one, but 8 divided by 2 is not 2. 8 divided by 2 is 4. And so it can happen to anyone, but the difference between people that get to fix their error, right, and do a little erasing and fix their error, and people who just turn it in incorrect are people who have some way of checking. So I think it's a good idea to do a checkpoint. So over 4 up 0. And now when I get my ruler out, the line goes through. And so I have all the time students come up to me while they're taking their test and they say, you know, you made a mistake. This one doesn't create a line. And so, but the story is they all create a line. And so if they're not creating a line, it's you who've made a mistake on somewhere along, or more than one mistake. I had more than one mistake on this, right? So when we started fixing my mistakes, notice there was more than one mistake. Okay, so we did lovely on that. see what we have up here. They're asking me to find the x and the y-intercept. And when the equation is solved for y like this, it's actually kind of, finding the x-intercept is kind of rough, I'll just admit it. Finding the y-intercept is cheese, though. It's easy. It's my favorite point. You plug it in, right? Y equals negative 1/3 times 0 plus 2, y equals 2. So that point, when the equation is solved for y, which they're going to give us a special name for it later on, we're going to get that special name. It's called slope-intercept form, I'll tell you right now. But when it's solved for y, it has a special name. Remember, when it solved x and y on the same side of the equation, it's general form or standard form. I think that last one we had right here was in either general form or standard form, depending on the book that named it, with x and y on the same side of the equation. So actually picking y to be 0 is going to be kind of rough, right? Because this is going to be 0 equals negative 1/3 x plus 2, right? And then I could take away 2 both sides. Negative 2 equals negative 1/3 x, and then put my finger on there and divide by negative 1/3, right? Which is, so this is divide by negative 1/3, and that's the same as multiplying by the reciprocal, which is negative 3. And so I would rather multiply by negative 3 than divide by negative 1/3. So I'm going to multiply here by negative 3, and here by negative 3. Barely fits in there. So on this side I get 6, so it didn't turn out as rough as I said it was going to. And the negative 3's cancel. Negative times a negative is a positive, and I just get x. X is 6. And I could verify that it works if I like. On the next test, you are not allowed a graphing calculator. And in fact, on no test in the class are you allowed a graphing calculator. So if your calculator will graph, you're not allowed it. Because that's what we're working on doing ourselves. And so you can see where I got 0 there, just as I checked it, right? That side there. And it is always good to have a checkpoint. If you don't know if your calculator is a graphing calculator or not a graphing calculator, come see me and I'll tell you. When I pick my checkpoint, I want to pick a value for x that is the same as the denominator of that fraction, which happens to be 3. So I'm going to pick my x value to be 3, and I'll go find that y value. So y equals negative 1/3. Any multiple of 3 would do. And I have that kind of already going on my calculator. Negative 1/3 times 6, because that's what I had for the other one, plus 2, and I was verifying. And so now I'm going to just edit that and put in 3. And I get 1. And then I'm going to plot these 3 points over 6, up 0. Since they're going to fit on without me rescaling, I don't have to label. If you plot the points without labeling, I assume that you counted by ones. And then a ruler to make sure that they all go through the same straight line. And so if you cannot lay a ruler down and have all your points on there like that, then that tells you that you have made a mistake. And so then they have us recall, this was just from the last section, that when it's y equals a number, you get a horizontal line. When x equals a number, you get a vertical line. When it has both x and y, you get a slanted line. And this one had x and y in it, and we got a slanted line. This one had x and y in it, and we got a slanted line. And the ones from the previous section, we had some horizontal and some vertical lines. And that's what they're going to actually show us to draw. And they call it by quick draw, as opposed to picking 3 points. And so notice it's a vertical line, identify it as such, and then you can draw it really quickly. And so if it has x in it only, it's a vertical line. So that's the first thing to notice is, it's it's vertical. And then I can quick draw it if it's vertical. I don't need to get 3 points on it. All I need is to know that it's vertical and 1 point. And how you can get 1 point is just go on the x-axis and plot your number. So here's my x-axis, plot -2, and now draw the vertical line through it. Okay. Now they decided to ask us a few questions while they were here. And the first question they're asking is, hey, where is that crossing, that line crossing the x-axis? Here's the x-axis, because that's the X-intercept. And, oh, well, it's crossing right here at -2, right? And we could write that as an ordered pair. As an ordered pair, that'd be -2, comma, 0. And my negative got lost in the line that was there. And this is one that people have trouble with, because where is it crossing the y-axis? And people will say that it's crossing the y-axis at, they'll put 0 is what they'll put, but you're saying it's crossing here in the center if you put that, if you put 0. And so what you need to say for this is none, is what your book says. It's not crossing the y-axis. There is not a y-intercept. I would also accept just as equally as none, like your book put, you could write, it does not cross y-axis. You could also put that if you wanted, but that doesn't fit on that line quite as well as none does. And so it doesn't have a y-intercept. And so putting 0 is not right. And so when people have 0, it happens all the time. People put 0 here and it's wrong. So I want to make sure that everyone knows, because you're saying it crosses here at 0. And so then horizontal lines have y only in them. So this equation only has y in it. And so I know, oh, it's horizontal. And the quick way of drawing it is to go on the y-axis and plot your number. So this says y, and so plot your number. So -1, -2, -3. And all you need is 1 point and the knowledge that it's horizontal. Horizontal is this way, like the horizon. The horizon, right? The vertical blinds, up and down the vertical blinds. And so they're asking me here, where does it cross the y-axis? Well, none. It doesn't cross. Where does it cross the y-axis? The shortcut notation is -3. And if you wanted to write it in ordered pair notation, that'd be okay too. That'd be 0 over 0 down 3. So we did a lovely job at those. And so you have to notice, right, what kind of line they are. So if they are horizontal or vertical, they're actually really fast to graph. It's just a matter of remembering which one is which. And again, if I had a nickel for every time I have been told by a student that I expected it to look like the x-axis, to be horizontal, I would be rich, rich, rich. And the same here. I expected it to look like the y-axis, but it doesn't. And so you have to be careful with that. If you wanted to pick points, remember how we picked points. This is the long way. X has to be -2, and y could be anything. And now I got some points over -2 up 0, over -2 up 1, over -2 up 2, right? There's my points. My line, I know, is a little bit, it's the best I could do under the nervousness of the situation. Everyone watching, all of the world watching. And so that is the problems that they had in 2.4. And so we'll stop there.